All right. Well, like I said, um, your midterm is coming up for lab. And so on that midterm, you're going to have to be able to do your unit conversions. I've already got a video up on YouTube of me doing some scientific notation, converting to and converting from scientific notation. But you're also going to need to know how to convert your units. And so if you'll see here, this is the chart that is in your lab manual. What I want you to do with this is change it or put it in a format that is easier for you to use. Okay, and what I mean by that is I want you to follow along with me right now, and I want you to draw what I'm drawing. Okay, draw a line and one perpendicular to that about half the page in length, just like that. Okay, basically a bracket. And we're going to list all of these different units in order of their size. Okay, and so what I want you to do is draw a line in the middle. Okay, and so here's going to be our large end, or greater than 1, and here's going to be our small end, less than 1 sizes. Okay, and so the biggest one you can see here is giga. And so we're going to write giga here on the end, and the size relative to the base unit here is 10 to the 9th. What I want you to write is just a 9. Okay, here in the middle is our relative unit. So we'll just say in this case it's either a meter, right, or it could be liter, or it could be gram, right? Whatever unit, base unit you are talking about, that's going to be 0. Okay, and so your chart doesn't even show that. Okay, 0 is what you're relating to. Okay, and on the far end of the spectrum, we see angstrom, and that is 10 to the minus 10th. And so I want you to write minus 10 over here. And then we're going to include all of them in here. And so you're going to break this section into thirds. Right, here we're going to write mega, and that's going to be 6. Here we're going to write kilo, or K, and that's going to be 3. Okay, we'll break this one into thirds roughly. Okay, except this time I put 3 lines. All right, and so let's see. Over here we have nano. This one here is angstrom. Right, here's nano, and that one is minus 9. Here's micro. Make sure you recognize that mu there is micro. That's minus 6. Okay. Here is milli. That's minus 3. And we also have 2 more in there. We have centi, as in centimeter, which is minus 2. And we have deci, as in decimeter, that's minus 1. Okay? And so anytime you have, you're going to have to memorize this, by the way. Okay? And so I'll just tell you right now, you're going to have to memorize how these units relate to each other. Okay. And so when you have a problem with unit conversion, you should draw this, because this will help you. Okay. Now what we're going to do is we're going to talk about 4 steps that you can follow to always get your unit conversions correct. Okay. And I'm going to write those steps out right now. Okay, number 1. When you get your problem, the first thing you want to decide is which side of the equation has a larger unit. Okay, and so the answer to number 1 is going to be either left or it's going to be right. Okay, for instance, if your question is, let's say, 1 nanometer is equal to how many meters? Right, so let's say this is the question you get. 1 nanometer is equal to how many meters? What you want to do is look at your scale here. Find nanometer right there at minus 9 and meter right there at 0. And so we know that meter is a larger unit than nanometer. And so the answer to the first part right here would be R, or you would have a larger unit on the right hand side. Okay? Number 2, you want to find out how far apart are they. Okay? And so first you want to know which side has the larger unit. The second thing you want to know is how far apart are they from each other, those units. And so we look here at nano, that's at -9. Meter is here at 0. And so the answer to that part would be they're 9 apart. Right? You don't need to put minus signs, just put 9. Okay? And so they are a distance of 9. If we were asking how far apart is, say, a decimeter from a micrometer, right? Decimeter is at -1, micrometer is at -6, and so they would have been 5 apart. And so you would have put 5 if that was the case. Okay, so you need to know how far apart they are. Once you have that information, you can then do your conversion. Okay, and so what you need to remember, I'm just going to write this right here. If the answer to number 1 was left, that's going to be a positive exponent. If your answer was right, that's going to be a negative exponent. Okay? And so we're going to answer this question in scientific notation. And so I want you to take the number that's given, which is 1 in this case. 1. You're always going to put times 10 to the something. Okay? What that something is going to be the number that they're apart. Okay? And so you got the 1 from here, where it says 1 nanometer is equal to, times 10 to 9 apart, and because you put right is larger, that means you're going to put a minus sign in front of that exponent. And so 1 times 10 to the -9 meters. Okay? And so 1 nanometer is equal to 1 times 10 to the -9 meters. And I said there were 4 steps. The 4th step doesn't always apply. Okay? The 4th step is the adjustment step if needed. And we'll do an example of what I mean by that. But basically, you want to look at your answer and see if it fits into scientific notation format, which this does. Right? Our decimal point is here, 1.0 times 10 to the -9. That is perfect scientific notation. Okay, so what we're going to do is we're going to go through a few example problems so you can get used to doing this. And so these are right out of the first thing you did on day 1 of your lab. And so I'm going to throw a couple of those example problems at you. First one. 1 millimeter is equal to how many nanometers? Right? So 1 millimeter is equal to how many nanometers? Let's follow our steps. Number 1, left or right? Well, if we look at our table here, here's millimeter, here's nanometer. Okay? So what that tells me is that this side is larger, and so our answer would be left. Okay? Number 2, how far apart are they? Well, here is millimeter, here is nanometer. Millimeters at -3, nanometers at -9, and so they are 6 apart. Number 3, do your conversion. So take your number, 1 times 10. Okay, now we know 6 is going to be our exponent, but was it going to be positive or negative? Well, left we said was positive, right is negative, and since this is left, that means our number is positive. So 1 times 10 to the 6th nanometers. Okay? So 1 millimeter is the equivalent of 1 times 10 to the 6th nanometers. Do we need to adjust? I'm going to write 4 here. Our format looks perfect. right? And so we don't need to do any additional adjustments on this one. Next, how about this one? 14 grams is equal to how many milligrams? Okay? Let's follow our steps. Number one, which side has a larger unit? Grams versus milligrams. So grams right here at 0, milligrams right here at -3. And so our left-hand side again is the larger unit. Number two, how far apart are they? Well, here's grams at 0, here's milligrams at -3, and so they are 3 apart. Number 3, let's do our conversion. Take our number, 14 in this case. 14 times 10, we said it was a left, and so left means positive, and so 10 to the third milligrams. Okay, now, number 4. Something's not right about this. Remember your scientific notation. Where is our decimal point? Our decimal point is after the 14. But in scientific notation, there should only be one digit to the left of the decimal point, and we need to move this over one spot. Okay? When we do that, every time that moves over one, that means we have to add 1 to our exponent. And that would give us 1.4 times 10 to the 4th milligrams. And that would be your answer. Okay? I'm going to do a couple more. Hopefully you're picking up on this. Let's see. 9 milliliters is equal to how many liters? Okay, first thing we want to look at. Number 1, which side has a larger unit? All right, if we look here at our scale, milliliters is at -3, liters is at 0, and so in this case the right hand side has a larger unit. Number 2, how far apart are our units? Liters is here at 0, milliliters is here at -3, and so we are 3 apart. Number 3, do our conversion. 9 times 10. Okay, look at our key here. We said it's to the right, then it's a negative number. So 10 to the -3 liters. Okay, is that the right format? That is the right format. Okay, so number 4, not necessary at this point. So there's your answer. Okay, let's do another one. Let's see. 1 microliter is equal to how many milliliters? Alright, first thing, which side has a larger unit? We look down here. Here's micro. Here's milli. So milli is the larger unit. Therefore, that's the right hand side. Number 2, how far apart are they? Milli to micro, distance of 3. Number 3, do your conversion. 1 times 10, right hand side means negative, 10 to the -3 milliliters. Okay, that is the right format, and so we don't need to do adjust. That is the right answer. Alright, last one. This one's going to be tricky. 17 centimeters is equal to how many meters? Okay, so 17 centimeters is equal to how many meters? Number 1, left hand or right hand? Centimeters, right here. Meters, right here. Meaning that our right hand side is bigger. Number 2, how far apart are they? Centimeters to meters, a distance of 2. Number 3, do your conversion. 17 times 10, right hand side means negative number, to the -2 meters. Okay, look at that. Does that meet scientific notation requirements? It does not. Again, we have 2 digits to the left of the decimal point, and so we need to adjust. So number 4, we need to move our decimal point over 1 spot. When we do that, that means we have to add 1 to our exponent. Notice minus 2 plus 1. That will give us 1.7 times 10 to the minus 1 meters. Okay? Notice this number goes to minus 1, not minus 3, because this is a negative 2 and we're adding a positive 1. Okay? And so anytime the decimal is moving that way, we have to add 1 to our exponent. Okay, I hope this has helped. If you have more questions or you want to do more problems with me, you can come to my office hours and we will get it all figured out. But I think this will be a good way, if you learn to memorize this and you remember these steps, then you will get every single one of your unit conversions correct. Okay, see you all in class.